Hello, in this video we are going to learn data visualization using SeaBorn. Here what is data visualization? Representing data in the form of pictures, graphs or charts and plots is called as data visualization. Okay, so for visualizing this data in the form of pictures, graphs or charts, we have to install SeaBorn package. Here SeaBorn is a Python library for data visualization, that means representing data in the form of pictures or graphs. Okay, to install this SeaBorn in your VS Code or any other IDE environment, just below given command. Okay, here in console, this pip install SeaBorn in your console. Okay, to install a SeaBorn package. After installing SeaBorn package, you can visualize the data, means you can convert the data into in the form of pictures or graphs or charts. Okay, we'll see with an examples how we convert, but we have to install this package here. Okay, so here SeaBorn is a Python library for data visualization, and also SeaBorn is a wrapper around Matplotlib library. Here Matplotlib library is also another Python library for data visualization, but SeaBorn contains more advanced features than this Matplotlib library, and also SeaBorn offers beautiful soft colors and uses simple and short syntax, and SeaBorn is faster than Matplotlib library. Okay, SeaBorn is a faster than Matplotlib library while rendering the graphs, and SeaBorn and Matplotlib library together we can also convert the data in the form of pictures or graphs. Okay, and using SeaBorn we can create different type of graphs. So these different type of graphs: distribution plot, count plot, box plot, scatter plot. Okay, so in this video we will see the distribution plot. What is distribution plot? And with an example we'll convert the data in the form of pictures or graphs. Okay, using this distribution plot. Okay, for that you have to install SeaBorn package and Matplotlib library package, and you have to import both of the packages, and in that methods and functions are there. Okay, so this, with that help of the methods and functions in the package, we can convert the data in the form of pictures or graphs. Okay, we'll see with an example. Distribution plot. Distribution plot here represents how data is distributed at certain intervals. The intervals are called bins. Okay, so how data is distributed at certain intervals, and these intervals have to store in bins here. Okay, similar to the histogram. Distribution plot is similar to the histogram. So to draw distribution plot we have to use displot function, and first we have to import this data set here, or mpg data set here. Okay, mpg cylinder, this shows each car and how much mileage is there. So mpg cylinders, displacement, horsepower, weight, these are different columns are there. We have to import this data set. To import this data set from the internet we have to use load underscore dataset function. Okay, simple. So before that you have to import these libraries also for data visualization: Matplotlib library, SeaBorn library. Okay, after importing these both libraries, and we have to import mpg dataset. Okay, and store is here mpg is equal to load underscore dataset. Okay, to load from the internet here. Okay, and pass mpg, simple, right? mpg is equal to, sorry, sns here, sns dot load underscore dataset mpg, simple. Okay, and SeaBorn has this load mpg data set here, and we have to loading from the internet here, simple, right? We got this one. See, mpg cylinders, displacement, horsepower, weight, right? Okay, so it returns the data frame object. Data frame consists of rows and columns. Next thing is we have to draw the displot function. Okay, displot function means we have to draw the distribution plot using displot function, simple, sns dot displot, and in displot we have to pass the which data set we are working. We are working on mpg, right here, mpg means here data frame here, mpg. Okay, and the question is, there is a question we have, no? So here, write a Python program to display distribution plot by taking number of cylinders on x-axis. Find out how many cars having how many cylinders. So if you look into this, there are so many cylinder values are there. Okay, so many cylinders values are there, 8, 4, 6, 5, 8. Okay, so how many cars having how many cylinders, we have to find it out. So for that we have to find the unique cylinder values. To find unique cylinder values we have to write this code here, simple, df is equal to simple mpg cylinders, right, dot unique method. Okay, unique method, simple, right, and just execute it, simple. We got this one, simple, 84635. So there are 5 unique values are there, so means we have to store 5 unique values means 5 in the bins here. Okay, means if there are 3 unique values, we have to store 3 equal to bins here, intervals. Okay, bins means regular intervals. Here simple, first we have to take the x-axis cylinders here, simple cylinders. How many bins are there? 5. Bins means intervals, regular intervals of time. We have regular intervals values here. Here bins equal to 5 here. Okay, bins means regular interval values. Here 5 values are there, means 5. If there are 3 values, we have to store bins equal to 3 here. Okay, that's simple. Execute it, right? And so we got here, observe here. So we have 200. Okay, 4 to 5 cylinders having 200 cars here. Okay, 4 to 5 cylinders having 200 cars, and 5 to 6, 3 to 4 less cylinders. Okay, so observe. Okay, we get 200 cars are there. We have 4 to 5 cylinders having 200 maximum cars, right? That's the task here. And if you want to show the cylinders, already we have shown the X label here, simple. For that we have to show the X label cylinders, because we are already, if you want to, you know, cylinders or cylinder number of cylinders. Okay, number of cylinders or whatever. Okay, if we want to give number of cylinders, right, plt.x label here, matplot library, just plot.show, simple. See number of cylinders and count value here. Okay, right? And suppose if you want the KD line, kernel distribution smooth line. Okay, for that you have to just write here KD is equal to true. KD is equal to true. If you want kernel distribution line, just write KD equal to true. So we got the kernel distribution line. Kernel distribution line is a smooth line. It shows how data was distributed. Okay, so higher densities value here means CC, observe, same, it follows the histogram only. Here 4 having maximum cylinder, maximum number of cars, 4 cylinders having, and next one, these 2 one having this 3 cylinders. Okay, so like that, kernel distribution line, KD equal to true. And if you don't want these bars, means just take out this bins equal to 5, right? And right here kind is equal to KD instead of KD equal to true. Kind is equal to KD, simple. Okay, just execute it, right? So if you don't want these bars, simply you want kernel distribution line, just write this kind equal to KD parameter. And if you want empirical cumulative distribution, those things, you can have to write ECDF. See, like that. This empirical is a different one, probability. So here, observe here. So if proportional densities. Okay, if you want proportional density, then we should display empirical cumulative distribution function. So this is a different one. This is based on the empirical value and based on step function. There's a different statistics. Okay, but if you want to draw proportional densities, just remember you have to write this kind equal to ECDF, simple. Okay, the simple one. And if you want the kernel distribution smooth line, you have to write kind is equal to KDE. Okay, without bars and with bars. And there is another program is there. So write a Python program to display a distribution plot by taking number of cylinders on x-axis and mileage on y-axis, and find out which cylinder having maximum mileage. We have to find the maximum, which cylinders having maximum mileage. For that we have to take the y-axis mileage here. Okay, simple. Take the y-axis mileage. Y is equal to mileage, right? And take the y label mileage here. Plot dot y label mileage. Simple. Okay, and we just execute it, simple. Plot dot x equal to y, y is equal to mileage here, x equal to cylinders. Okay, instead of mileage here, not observe here, mileage is mpg here. Okay, mileage is mpg here, so y is equal to mpg. Just execute it. See, observe here, number of cylinders, mileage. So here 4 to 5 cylinders having maximum mileage. Okay, the task is how many cylinders having, find out which cylinder is giving maximum mileage. So here 4 to 5 cylinders giving maximum mileage. Just we are using this plot function, we are passing the data, which data set we are using, and x-axis cylinder and y-axis mpg. So using this plot function, we can observe that here maximum number of mileage giving 4 to 5 cylinders. Okay, by observing this graph. Okay, so not only cylinders, suppose if you want to draw the distribution plot for the origin, suppose here origin is a different country origin, USA. If you want to know unique origin values, just instead of cylinders use origin here, origin. Okay, just execute it. See what are the unique values: USA, Japan, Europe. So you have to take the 3 bins here. Okay, 3 bins, simple. Instead of I equal to mbg, bins equal to 3, bins equal to 3, right? X is equal to origin, means how origin data has distributed. Okay, distribution plot means how data was distributed. Okay, origin, observe, see, observe here, USA, Japan. Okay, take out this mileage, there is no mileage here, y label, and plot give origin here, simple, X label. Origin, right? Execute it, simple. Okay, USA having maximum number of cars 250, and Japan having 100, almost 50 to between 100. Europe also having between 200. USA having maximum number of cars or origin. Okay, in this data set USA having maximum number of cars. Okay, origin cars. Okay, so like that. Okay, so if you want to know the different kind of model RNAs, if you want to try this one. Okay, how model RNAs got distributed here, 70, 71, 72, so both are there. So find out the unique values and give the bins here. Okay, bins means regular interval values, right? To draw the distribution plot, bins is important here, regular interval values here, and x-axis and y-axis, and pass the data set in this plot function to draw the disk plot. Simple. Okay, so that's about the disk plot function. So next video we'll see the count plot.